Hey, geometry friends, here we go. We're marching through chapter 5 on 3D geometry, three-dimensional geometry. And last 10.4, we went over the surface area of prisms and cylinders. And now we're going to visit our pointed friends, our pyramids and our cones. And so you'll see there's similarities to what we talked about last lesson, but along with some slight changes due to the new shape. So let's check out our definitions. The first definition is slant height. That's a new term. Haven't seen that before because cylinders and prisms were both, remember, they were right cylinders and right prisms, so they were always at 90 degrees. Now we've got slanted shapes, the cones and pyramids that rise up towards that common vertex. So what is a slant height? Slant height is the distance from vertex to the middle of the side edge. Okay, and so what's really important about slant height is it runs along the sides of the shape. So if you're up at the top of the pyramid and you went sliding down to the bottom and then hit at the bottom edge and you had to go and you went right down the middle, that's why I've got these little indicators right here, is that it hits right in the middle of the side if it's a pyramid. If it's a cone, doesn't matter, it just means it hits it at a right angle. That is your slant height. Okay, almost like if you had to climb up that shape, that's the distance you would cover until you got to the top. You'll see in a minute why that's important. Because we also have something called altitude. And altitude is the perpendicular distance from the vertex to the base. Okay, we could most commonly just think of this as height. Okay, in fact, a lot of times it's even designated with an H for height, as I've done over here. Okay, and so because you can see slant height is not the height of the shape. Okay, the thing is a certain height from the ground, but you crawling up the side, that's a longer distance. That's actually like a hypotenuse. Whereas altitude is more like a leg. And you can see that's why there's a right angle. It goes straight from the top of the vertex and down at a right angle to the base. And that's your altitude. So know the difference between slant height and altitude because you're going to see in the formulas it makes a difference. So how do you find the surface area of a pyramid? Well, it's similar to last lesson in that you're going to first find what we call this lateral area surface area, and that is the sides. Okay, so in other words, you're going to do all of these, the three triangular sides on the pyramid first. And that's why you can see that formula for that is a lot like, would be like a triangle. Triangle is 1/2 base times height. In other words, if I just found the area of this triangle and then multiplied it by, in this case, 4, because there's 4 sides to this one, then I would have the overall side area. So rather than say I'm going to find the triangle, multiply by 4 or whatever, we just say, well, I'm actually going to use the entire perimeter all at once, and then that will actually help me find the area of all 4 sides in one fell swoop. Okay, so that says 1/2 times perimeter times, notice that L represents our slant height, because we're not interested in the altitude, we are interested in the height of the face of the pyramid. And then now, instead, just like last lesson, we added 2b, because remember, prisms have the double base, pyramids only have, and cones only have one base. So now we just have a single b that's being added on to this formula. Cones are similar, but again, because they're circles, they're different. And that is, again, you have your lateral area here added to your base right here. Okay, and so the lateral area of a cylinder, of a cone, is pi r slant height. So pi times the radius times the slant height. And we'll discuss in class why that is the case, but it's similar in a way to our circumference formula. And then the base of a circle is a circle. And so that's why right here for the base, we just have the good old pi r squared, because that's how that'll give us our base down here. Okay, so 2 new shapes, pyramids, 1/2 perimeter, basically height. It's like we had height, but again, it's the slant height, so be careful. So I'll just keep saying slant height, plus 1 base. And then for a cone, pi r slant height plus the base pi r squared. Tricky part of this lesson is not necessarily calculations. If you can show your work and be deliberate by step, you'll be fine. It's just going to be the need to memorize the formulas. So I encourage you to start making flashcards or notes of that and practicing. Do I know my prism, my cylinder, my cone, and my pyramid surface area formulas? Okay. So let's get to the questions. So question number one is, what is the difference between slant height and altitude? Okay, and we'll just revisit it. I've already said it once in the video, but altitude is the actual height of the pyramid. And so we call this altitude or height. Okay, whereas slant height is the surface distance of the vertex to one of the sides of the shape. Okay, and so that we have slant height here. All right, and so notice all the formulas for surface area have to do with slant height. And so you're going to pretty much ignore altitudes unless all they do is give you an altitude, and then we're going to talk about how to use the altitude to find slant height. So again, slant height is kind of the surface distance. I'm not going to directly restate it since we'd have the definitions above. Whereas the altitude is more of the internal distance. But again, probably the easiest way to think of it is simply the actual height of that pyramid or cone. Okay. Number two, it says that you have to find the base for any of these shapes. How do you figure out how to calculate the base of a pyramid or cone? And I'm asking that just so you realize there's a flexible point in all of these formulas, because they can all depend on what the shape of that base is. You're going to find the lateral area and you're going to add the base. Well, sometimes the base here is a triangle, like this first one I've drawn in red. So in that case, the way that I'm going to find that red base is 1/2 base times height, because that's the area for a triangle. If my base is a rectangle, well, then that's just going to be length times width. So how you calculate the base will always change. If your base is a regular polygon here, like a, what is that, 1, 2, 3, 4, like a hexagon, well, that's going to be 1/2 AP. So all those area formulas we learned in previous chapters, they're coming into play. They're not something you want to just forget. You're going to have to keep using them. And then, of course, we already talked about, if it's a circle, well, then that's why we just pull out the regular pi r squared. So whichever one you happen to get, oh, wait, let me do better than that. These are all just different types of bases, and you use the appropriate one depending on the shape that you're looking for. All right, now let's do, last two problems are just actual calculations. So let's calculate the surface area of a pyramid with base, it's a square pyramid with base 5 and a slant height of 12 centimeters. Okay, well, let's pull out our formula. Surface area equals, if we remember, it's perimeter times slant height plus the base. Okay, so in this case, the perimeter of that square would be 5 by 5 by 5. So that's just going to be 20. 4 times 5 is 20. Times the slant height, they gave it to us, it's 12. Plus the area of the base. Again, the base here is a square, so side times side, that's 5 times 5. So we just get 25. Square bases, super easy. Triangle, work a little bit harder. Pentagon, you're gonna have to work a whole lot harder. Sometimes the hardest, most labor-intensive part of one of these is having to do that, calculating the area of like a regular hexagon or something. In this case, it's not so bad. So we get, oh, and I actually forgot a key part of our, because the sides are triangles, there's a 1/2 here. So hopefully you were screaming at me in the video saying, Mr. Medford, don't forget the 1/2. So 1/2 times 20 times 12, that's basically 10 times 12. And so we get 120 plus 25. And so we get a surface area of 145 centimeters squared. Okay, so don't forget that 1/2 perimeter slant height plus the base. Okay, just do one more shape. Well, we practice this for the first time. Let's try it with a cone with a diameter of 28 meters and a height, not a slant height, but a height, or I could have said an altitude of 22 meters. So let's take a look at this. Our formula is, we just need to find it is pi r times the slant height plus the base, which is going to be a circle of pi r squared. So the reason this problem is a little trickier than normal is we do not know the slant height. I don't know this right here. I know the actual height, so don't plug 22 in there. You'll be toast. So here's the extra step. How do we find this distance here, knowing this distance here? Well, if you can imagine that, you have a vertical distance like this, and then you have the slant height here. You've basically created a right triangle. Okay, and so we're going to use Pythagorean theorem to take the height or the altitude and find the slant height. All right, and so we can see this is a triangle. I'll redraw it right here. Scroll up a little bit. Whose height is 22. This is our slant height right here. And now what's that distance? Well, it's always down to the middle of the base, and the whole base across is 28. So this would be 14. So if I do 22 squared plus 14 squared, I get my slant height squared. Okay, and so in crunching those numbers, what we're going to get, I'm going to just for the sake of time, 22 squared plus 14 squared, that equals a slant height, after I square root it, of 26.1. Okay, I want to say it was something like 580 equals L squared, but again, just for not make this video too long, we've been doing Pythagorean theorem for a long time. We get 26.1 meters. Okay, so if I go back to my drawing, I now know this right here is 26.1, which again, the slant height should always be longer than your altitude or your height. So it seems like a reasonable measurement. So now I can begin to plug things into my formula. Pi times the radius. Careful, radius is not 28. The diameter is 28. So we cut that in half. My radius is 14, and my slant height is 26.1, plus pi times my radius again, 14, squared. Okay, if we crunch the first half, which is again the lateral area, we get 1,147.4 plus and a base of 615.44 for a grand total of 1,762.8 meters squared. Okay, so again, you can get some big numbers. That's why we're getting our calculators out, so we're not borrowing and, or not borrowing, but adding and borrowing and all that sort of stuff, carrying over. Main thing is strategizing that we know our formulas and we can plug things in properly. We can find our slant height from our altitude, et cetera, et cetera. Again, the same process, lateral area plus the base. Though with cones and pyramids, you only have one base. And sometimes you'll have to use this little trick to take the height or the altitude and find your slant height right over here. Okay, time to get organized, time to crunch some numbers, time to have some fun finding surface area. Look forward to practicing this in class with you. See you soon.